So excuse the thunder, we've got a bit of sound effects, but just a little bit of information. I know that is a concept that you guys all struggle with. If it says find the inclination of a line, okay? Now inclination is always from the right angle, from the right side up, okay? So if I have an angle, inclination is always from the right side up. Always, okay? So if I said to you, find the inclination of AB, and I have a line AB, let's go here, let's say A is 1 and 4, and B is -2 and -1. You're going to say M equals tan theta always, okay? And your gradient of AB will equal 4 plus 1 over 1 plus 2, which is 5 over 3, okay? And then you're going to say 5 over 3 equals tan theta. And you say shift tan 5 over 3, and you get the answer. So let's go shift tan. You've got beautiful fraction buttons, 5 over 3, and you get an answer of 59. Theta is equal to 59,04 degrees. Now remember degrees, okay? So that's always looking for, let's do it in the color, theta over here, okay? Let's say I asked you for the angle, angle of inclination, and AB in this case was a negative line, a negative gradient. So let's draw a line, and let's say A is the point -2 and 4, and let's say B is the point, I'm just making up 3 and -2. So then you're going to say M is equal to, M of AB is equal to 4 plus 2 over -2 minus 3, which is 6 over -5. So it doesn't matter the numbers, and we're going to say M equals tan theta. And you're going to say shift tan -6 over 5. And you get an angle that's negative. Your calculator is going to give you an answer that looks like this. -50,19. Now, if you were just looking for the angle on the left-hand side, if we were just looking for this, that angle there is 50,19. You can just take away the negative. However, because inclination is always on the right-hand side, you're going to say plus 180, okay? And you land up with this angle here, with the angle of inclination is 129,81. So theta, or the angle of inclination, is 129,81. And why I'm stipulating always angle of inclination is more than likely, not always, more than likely they won't ask us angle of inclination. They're going to ask us, let me take that away. They're going to ask us how to do, let's actually just draw a ruler here so that we've got, just dividing the page. And let's say we have now, I give you a line, let's draw this. And let's draw, hypothetically, we're just going to make up a picture. A is 2 and 4, and B is 5 and -1, and C is -3 and -1. Or let's say -2. And I want find CAB. I want that angle up there. Okay? So now, you can't ever find an angle in the middle. When you're using M equals tan theta, we are always finding angles here on the x-axis and here. We never find one here. So we're going to find this angle and this angle, and then do 180 degrees minus theta. So we find this angle using this gradient, and we find this angle using this gradient, and then 180 degrees minus, and it always works. I don't do construction, I don't do constructing lines. This always works. So let's say we have here, the gradient of AC is equal to 4 plus 2 over 2 plus 3, which is 6 over 5. So 6 over 5 equals 10, and we're just labeling it different things, theta 1. So shift tan 6 over 5, shift tan 6 over 5, and we get an angle, theta 1 is equal to 50,19. Now that's going to be over here, theta 1. That angle there is 50,19 degrees. Okay, then we go and do the gradient of AB. So M of AB is equal to 4 plus 1 over 2 minus 5. And it's going to be 5 over minus 3. So you're going to say minus 5 over 3 equals tan theta 2. Okay, so shift tan minus 5 over 3. And we get, sorry about that, theta 2 is equal to, now it gives us on our calculator minus 59,03. Now remember, I showed you that if it says minus, we just take it, just because it's a negative gradient, we just take away the negative and that's positive. If I ask you for inclination, it's here, but we're not looking for that angle, we're looking for this angle. So all I'm just going to do is take away the negative and say, let's get our pen back, we're going to say theta 2 is 59,04 degrees. Okay, so this over here is 59,04 degrees. And therefore, we can go and say, therefore, CAB, angle CAB is equal to 180 degrees minus 59,04 minus 50,19. So it's 180 minus 59.04 minus 50.19, and you get 70,77 degrees. And that always works. So you always remember, and just out of interest, like if we have a triangle, that, let's say, lies on the, let's draw an axis here, and let's draw an axis, a nice axis. Now I'm using a ruler, so okay. And let's say there's Y and there's X, and let's just draw a random picture up like that, okay? And I want that angle. And let's say A in this case is 2 and 5, and let's say B is minus 2 and 1. Again, I'm just making up these values, and this is 4 and 2, okay? And I want BAC. Find BAC. So in this case, I said you have to have a triangle on the x-axis. I'm going to extend this x-axis over here to there, okay? And what I'm going to do is I'm going to extend that line down to there and that line down to there. So now I have a triangle like that on the x-axis. So I'm going to find gradient of AB to find this angle, and I'm going to find gradient of AC to find this angle. So we're going to say M of AB is equal to 5 minus 1 over 2 plus 2, which is 1. So you can say 1 equals tan theta 1, and you get theta 1 is equal to 45 degrees. Okay, then we're going to do the gradient of AC, which is going to be 5 minus 2 over 2 minus 4, which is 3 over minus 2. So minus 3 over 2 equals tan theta 2. And you're going to say shift tan minus 3 over 2. And we get an answer of, we get minus 56,31 again. And remember I told you we can just literally take away the negative and say that's 56,31. So theta 2 is equal to 56,31 degrees. And therefore, BAC, which we wanted, is 180 degrees minus 45 minus 56,31. And that's sum of the angles of a triangle. So let's do it on our calculators. And you don't do anything in your head because you don't want to lose any careless marks. And BAC is equal to 78,69 degrees. So in geometry, analytical geometry, remember angles have a copy and have degree signs, and it's very, very, very important to know all of this. And you just learn my work, apply to every sum, and I promise you every single sum is the same. Okay, so we will put a little happy face there because we know that you're going to get it right, and I look forward to seeing you in the next lesson.